So now that we have the hole bored, let's move on to the next operation and mill this slot. Okay, so let's take a look at the drawing here and see what we have to do. We have a slot milled in one side of this part. The width of the slot is 0.625 plus 3 thousandths minus nothing. Okay, it's a little tighter tolerance than we've been using. The length of the slot is 5.81 inches. Okay, there's those two place decimals again, so that's a real loose tolerance on the length, fairly tight tolerance on the width. Okay, and the depth of the slot is 0.625 plus 3 minus nothing. Okay, so another fairly tight tolerance. That's to clear the length and width of those knurl holders we made last time. All right, earlier. So it's a slot like this is super easy with a digital readout. All you got to do, we're already centered up on the part and the slot. So all we need to do is subtract the diameter of the end mill. In this case, it's a 3/8 diameter end mill because the corner of this slot has a radius of 3/16. If you can see that, there we go. So I'm just using a 3/8 end mill. We'll allow the end mill to generate that corner radius. So 3/8 end mill. If we're using a DRO or a digital readout, all we do is subtract the 3/8 from the width of the slot and from the length of the slot, divide by 2, then we know how far to travel in all four directions to create that rectangular cutout. Okay, super easy. But if you don't have a DRO, it's a little more involved. Not a lot, but a little bit. So we're going to do it that way today. Okay, I'm going to use the dials. I don't use dials much anymore, but I know a lot of you guys have mini mills and bench mills and other mills that don't have digital readouts. So we're gonna do this slot today using the dials instead of the DRO. So the first thing I think I'm going to do is I'm going to put a mark on each end of this slot. It's 5.81 inches long. So I'm just going to figure out what the distance from the end of the part is to each end of the slot, put a scribe mark, and that's going to be the visual end of our slot. Like I said, this is a two-place decimal. It's not critical. You can easily mill to a line, and that's what we're going to do. So let's do a little calculation here. The part is 6.75 inches long, and the slot is 5.81 inches long. So subtract that. Okay, divide by 2. Tells me that the ends of the slot are 0.47 inches from each end of the part. So let's just take digital calipers here, set it for 0.47 inches, right about there, lock it down, and I'll just put a scribe mark at each end of the slot where the slot's going to be, just as kind of a guide to tell me where to stop. You can either use that and visually stop, or you can just mill to it and set the dial on your machine. Your table has 2 dials, right? So we can mill down to one end of the slot up to the scribe line, set one dial to 0, mill to the other end, set the other dial to 0, then you know exactly where to stop. Quick and dirty. Nothing fancy on the length. For the width, since we're not using a digital readout, we have backlash to deal with. So what we're going to do is we're going to mill one edge of the slot to size. Okay, this front edge, I'm going to mill it to its finished position. Actually finish it right up. Okay, and then once we get that surface milled, we can use gauge blocks to check and get the width of the slot right, milling the other side. Okay. So we're going to start out, we'll mill the 2 ends and mill the front edge of the slot to finish size. So the first thing I'm going to do is I'm going to rough this slot out, okay? We're already centered up on our part, so let's set the y-axis to 0 and lock the table down. We're just going to be taking one pass right down the middle with this 3/8 end mill just to give us a start on the slot. We'll take that down to almost to depth, maybe 10 thousandths shy of the depth. Okay, we're centered up on the part. Let me go turn the power on. Okay, now we need to pick up the top surface of the part. So what I'm going to do is I'm going to run my end mill down just above the top, set the stop, run it down hard against the stop, and lock it down. Okay, so that end mill's against the stop now. Now I'm going to move over. Let's get our RPM bumped up a bit here. Okay, now I'm going to bring my table up until the end mill scratches the surface. And we'll just kind of come down a little bit at a time until it just scratches, and I'm going to set my dial to 0 on the table. That's our reference for Z. So now we can come down, we can plunge cut if we want, or we can come down a little bit at a time and just rough this slot out. Let's move over to our scribe line on this left side here. Over about there. Okay, I'm going to set one dial to 0. And you guys probably can't see much. Let me zoom in a bit here. There we go. As you can see, I came over and up to that scribe line and set my dial to 0. Let's go down the other end and do the same thing. I'm just visually picking up that line. Remember, the length's not that critical, so we'll just go up till it just breaks the line. Then I go set the other dial to 0. So that establishes each end of the slot. Okay, now let's move the table up. The depth of the slot's 0.625 plus 3 minus nothing. Let's go up about 595, or no, about 615, about 10 thousandths. Leave about 10 thousandths for a finished cut. 1, 2, 3, 4, 5, 6. 15, okay. We'll leave a little bit of meat to clean up for a finished cut. Now make sure your y-axis is locked down. I'm going to plunge cut this out. I like plunge cutting. It's actually faster and easier on the tool than side milling for roughing out. Moving over about maybe a quarter the diameter of the end mill. You can remove a lot of metal in a hurry, and it's easy on the end mill, and it doesn't tend to plug up the flutes like it does side milling. Especially in aluminum, gummy material like aluminum. I'm doing this dry, and there's still no problem with chips sticking to the end mill. Alright, let's go do the same thing to the other side. It's about 100 thousandths per cut. Get much more than that and it slows down. Get much less than that and you're just wasting time. So you can tell when the end mill's happy. cut nice and easy. Alright, now stop a little bit shy of 0 here. We'll again leave a little bit extra material to clean up. Alright, so we got a rough cut down the middle of that slot. Now what I'm going to do is I'm going to move over a little bit, take a clean up cut on the front edge of this slot, and we can get a measurement from the front edge of the part to the front edge of the slot. And we can look at the drawing, we can figure out what that's supposed to be. We'll finish that right to size. So let's go ahead and do that. We're using a 3/8 end mill for a 5/8 slot, so we have about 3/16 of an inch per side to take off. It's a lot of stop. So we can move over 15 or 20 thousandths, any amount, doesn't matter. Just move over a little bit, set your dial to 0, and then take a cut. I'm going to go back and take a little spring cut as well, just to make sure everything's cleaned up nice, because this is going to establish our location of this slot. So now we need to figure out how far this needs to be, what this dimension needs to be. Let's just look at the drawing. The width of the part's 2 3/4 of an inch. Let me back up here a little bit. Whoop. Okay, the width of the part's 2 3/4. Width of the slot is 5/8, 0.625. Divide by 2. Okay, the slot should be 1.0625 from the edge of the part. Let's see what it is here. This dimension is not super critical, okay? It's a 3-place dimension. If you look on the print, we have plus or minus 5 thousandths of an inch tolerance on a 3-place dimension. So what we have now is 1.173. 1.173. So we got 110 thousandths to go. Remember I said we had about 3/16, about 188 thousandths, so we got 110 left. So let's go. What I'm going to do now is since I like working to 0 on my dials, I'm going to offset my dial 110 thousandths. Counterclockwise in this case, so as I keep feeding in, when I end up at 0, the slot will be finished. The edge of the slot will be located. So let's go ahead and take all but about 10 thousandths of that off, and then double check our dimension and see where we're at. Zoom in so you can see a little better. You may have to take this in more than one cut on your machine. This one doesn't care. I'm taking it all in one cut. About 110,000. back and take a cleanup cut on it. Alright, we'll leave it set right where it is. Take another cut just to clean it up, take all the spring out of the end now. Then we'll take a measurement, see where we are. It should be about 10 thousandths from our finished goal, which was what, 1 1/16. So I'm going to write that down. It's getting harder to remember. 1.0625 should be our distance from the edge of the part. So let's measure that, see where we are. We should be about 1.0725, right? Okay, we are at 1.071. Okay, so that means we have 8.5 thousandths to go. So let's go ahead and take that, right to size. I'm also going to go all the way to the end of the slot this time. I'm not going to worry about the bottom yet. We'll finish that up later. Just go ahead and take this to size. 8.5 thousandths I said, so right there. Finished cut will go all the way across the whole length of the slot. Go back and do it again. Just make sure all the spring is out of the tool. Try not to get in the way of the camera here, but it's hard to see the dials if I don't, so bear with me. Alright, this should do it. Okay, let's see what we have here. Should be 1.062 or 3, somewhere in there from the edge of the part. 1.064, okay? That's good. Remember I said we had plus or minus 5 thousandths on a standard 3-place dimension, so front edge of the slot is finished. So now let's take the slot to width. So let's go back and take, same way we'll take a cleanup cut on the back side of the slot, then we can measure the width. Start working on that. Again, I'm not worried about the bottom now, we'll do that last. So let's go back so it touches the back side. Nope, that's not quite enough. Still not quite enough. There we go. Alright. I'm going to reset my dial to 0 on the Y-axis. We're working on the width of this slot now. We got the front edge of it located. Now we're working on the width. We want to end up with 625 plus 3 minus nothing. Let's see where we're at. We can get close with the digital calipers, and then we'll switch to another method for the final measurement. Right now we're about 512. 511. Okay. Alright, 0.625 minus 511 means we have 114 thousandths to go. So let's go ahead and take most of that off. I'm going to offset my dial 114 thousandths. So we'll end up at 0 when the slot's at the right width. I'm going to take off all but about 10 thousandths now, just like we did on the front edge. Pardon me while I check the dial. Alright, let's go ahead and take a cleanup cut or a spring cut here and see where we're at. A couple spring cuts, so it won't hurt. Make sure to get all that spring out of the end now. This is a pretty tight tolerance, plus 3 minus nothing. It's pretty tight. Enough to get your attention. Alright, see where we are with the dial calipers. About 618, okay, we're shooting for 625 plus a little bit. So I think we can safely take another 5 thousandths off. And then we'll switch to another method of measuring it. Let's go another 5. Take a spring pass. Now let me go grab another tool here. Okay, what I have here is a adjustable parallel. This is really handy for measuring the width of slots. Okay, all it is just a sliding parallel. This one goes from 1/2 inch to about 11/16. So our 5/8 slot's right in the middle of its travel. Okay, so all you do with these things, slide them over to one side so they're smaller than what you want to measure, and then put them in the slot and open them up, slide them until they grip the slot like that, okay? Then you can just measure the adjustable parallel and it'll tell you how wide the slot is. It's another form of transfer measuring device like the telescoping gauge. Okay, so what we have, the slot is 623.5. Okay, so we have 1,000th and a half to 4.5 thousandths to go. Okay, remember we have a plus 3 minus nothing tolerance. So let's split the difference. Let's go about 3 thousandths. That'll put us right in the middle of our tolerance. So let's move down to the other end of the slot. There. Go down to depth. And move over 3 thousandths. And this will be our finished cut. But then I like to do spring passes, so we'll take at least a spring pass or two. Taking another cut without changing any settings. Get all the string out of the end. Same thing on this end. So hopefully that'll put us within our tolerance, okay? A really good way to check the width of the slot is using gauge blocks. Here I have 2 stacks of gauge blocks. This one's built up to 0.625. That's the minimum, the small end of the tolerance. This one's 628. That's the large end. So what we have here is essentially a go, no-go gauge. Go gauge should go in the slot. The no-go gauge should not. Okay, here's the 128 stack that will not go into the slot. Here's a 625. That doesn't go in either. It should. Let's see here. And the reason it doesn't go in is because I grabbed a 141 thousandths gauge block instead of a 125. Hold on a second. Alright, an honest mistake, only one row off. So here I have a 125 gauge block and a 1/2 inch gauge block. Gives me my 625 dimension. This one should go in. It does, look at that, okay? That's our go gauge. This is our no-go gauge, it will not go in. Okay? Make sure your slot is to size all the way to the bottom. End mills have a nasty habit of deflecting. Okay, see this one's doesn't quite go all the way to the bottom, so I'm going to take a couple more spring passes on this just to make sure it's cleared up. Let's see. Let's see what that did. Alright, almost. It just about gets to the bottom. I'm going to take another 1,000th off just to make sure it goes all the way down. Otherwise our other parts won't fit in it. This should do it. That's better. All the way to the bottom. Okay, the slot's good on width. Let's do the bottom of it. So I'm going to take I'm about 10 thousandths off of our depth now, so I'm going to take another 5 off, and then we'll measure that. Go down against the stop, raise the table up 5 thousandths. And I'm just going to move back in the middle of the slot. We don't care about the edges for the moment. Stay away from those. Take a reference cut along the bottom, and we'll measure it. And for measuring the depth of a slot, there's nothing better than a depth micrometer, okay? Let's see where we're at. Try to make sure all the burrs are off the edge of that thing first. Okay. Make sure all the chips are out of the way. You have to be careful reading depth micrometers because the numbers on the barrel are backwards from micrometer. You measure on these, you measure from right to left. Okay, I don't know if you can see that. Okay, so what we have here is about 619 and a half. Everything's backwards. Alright, 619 and a half. Okay, so we have about 5.5 thousandths to go to the minimum dimension, plus 3 minus nothing. So let's go about 7 thousandths deeper. Okay, that'll put us right in the middle of our tolerance. Raise the table 7 thousandths. Go to the end of our slot. Back side, and then we'll clean up the ends as well. So we've lost our location for the front of the slot. So since we're just cleaning up the bottom, what I usually do is just put a couple marks on it. Then we can refine the location with those marks. Don't even go all the way down, just move it over till you scratch the side a little bit. Take those marks off. Right there, make a note on the dial as to where you are. Let's see, we're about 67 thousandths. Let's go all the way down, over to the end of the slot. Out to our 67 thousandths dimension and then clean it up. Now we're not taking anything off the front. We're taking, what did I say, about 7 thousandths off the bottom. And we might as well go all the way around. Clean up the ends of the slot and the back of the slot. You're still set on 0 for the back. There. Back to 67. Okay, we're all the way down. We've been all the way around the slot. Check the depth. If it's good, we're done. We don't have to worry about burrs anymore because we didn't take anything off the edges. So now we should be about 627 and a half, thereabouts. Okay, we are still, well, about 626. I'm going to take another 1/1000 and a half off just to make sure. I like to be in the center of the tolerance. Well, let's see, not 1/1000 and a half, half a thousand. Yeah, we're at 620, almost 626. We'll go another 1/2,000 in the depth. To 67 on the front. That was my magic number. Should have wrote that down. And that should do it. Now we can take it out. We're done on this side. Okay, so that's it. So next thing we do, we'll flip it over, put the counterbore holes on the back side, the two set screw holes in the edge of the part, and the two other set screw holes or adjustment screw holes in the ends. So that'll be next. Okay, I guess just for grins, we had to see if we did this all right. So we had to try it with our knurl holders we made earlier. Let's make sure everything goes together. Okay, goes in the slot. That's a good sign. Feels like there's a little bit of a step here. That's a good sign. I think we're good to go. So I think what I'll do is I'm going to upload this video now, and then when I can be working on the next step while it's uploading. So I'll do that, and I'll talk to you later.